Hello, welcome to the new lecture on Chomsky's normal form. In last class, we have discussed how to simplify the grammar by using three techniques. First one, by eliminating epsilon productions, by eliminating useless productions, and by eliminating unit productions. So, keeping these three methods in mind, we have to convert the given context-free grammars into a standard form, that is Chomsky's normal form. Chomsky normal form. So now, what also called as CNF, Chomsky normal form. So what do you mean by this? Chomsky normal form is, it is a standard form in which any productions will be of this kind. That is, one non-terminal symbol is giving you two non-terminal symbols, or one variable giving you two variables. This is one type of the production you can see in Chomsky normal form. And the second type of the production that you can see in Chomsky normal form is A tends to A, is the other production where you can observe here this A is terminal symbol. So there can be two types of productions in Chomsky normal form. One is a non-terminal symbol giving you two non-terminal symbols, and a non-terminal symbol giving you a single terminal symbol. So all the productions should be in this format to say that the given grammar is in CNF. Okay. So now, let us take an example. Here, in this example, you can clearly see all the productions that you have here. S tends to AS, it is in CNF. S tends to A, CNF. A tends to SA, it is also in CNF. A tends to B, this is also in CNF. All the productions are in the standard format of Chomsky's normal form. But on the other side, you can see these two productions that we have highlighted are not there in Chomsky normal form. First one, okay, this is in Chomsky's normal form. This is not in CNF, this is in CNF, and this is not in CNF. So somehow we have to convert these two productions into its equivalent, Chomsky's normal form. So how do we do that? We can do it by adding more productions. So we'll see how that can be done. Okay, now see here. Okay, let me come back to this. See, what we can do here is, we can take two productions. See, I'll add a new production, that is, let us consider a new production as X tends to small a is one production that I am adding here. So what will happen to this particular production here? This production can be written as A tends to X. See here, a non-terminating symbol is giving you two non-terminating symbols, right? So now this one line I replaced with these two productions, in which both are in what? Chomsky normal form, right? So next what I do, here you can see the value, suppose let us consider I have AA, no? These two AAs, I'll combine it together and I'll call it as a VA, a new variable. So now I can add that new production VA tends to what? AA. which is in Chomsky normal form, where you have one non-terminating symbol giving you two non-terminating symbols. And finally, these two AAs will be changed to what? VA, where one terminating symbol is giving you two non-terminating symbols. So finally, the overall grammar can be written as S tends to EAS. That is the first production, this one. And the second production can be written as S tends to VAS, where what is VA? VA is AAA, right? And the third production is, what is third production? A tends to SA, and the fourth production you can see here, A tends to AA we have, but here we are replacing small a with capital X to put it into Chomsky normal form. So we can say capital A tends to what? XX, and X tends to small a. Now, this entire grammar is in Chomsky normal form, which we have obtained from this given grammar. Isn't it? So this grammar that you can see here is converted to Chomsky normal form. This is one example. So now let us see a few more examples in conversion to Chomsky's normal form. So look at the given grammar. Here we have the productions which is not in Chomsky normal form, right? For example, you can check here, this A is violating Chomsky normal form. This S and B, we cannot have three non-terminals. I mean, we cannot have three terminals. That should be only a single terminal, right? And here on right hand side, both should be variables, but here one is variable, one is terminating symbol. Here two are what? Variables, and one is terminating symbols, right? So what we do here, we have to convert this into Chomsky normal form. So how do we do that? See, we introduce three variables, that is TA, TB, and TC. So what is the use of TA, TB, and TC? Look at the grammar here. I have three terminating symbols. What are the three terminating symbols? Small a, small b, and small c. So I want these terminating symbols to be replaced with a non-terminating symbol. So what I do, I will add three productions where small a is replaced with TA. You can see that here. A variable, here also small a is replaced with TA, and at the same time you can see small b is replaced with TB, right? And small c is replaced with TC by writing their equivalent productions. This is step number one. So what you do in step number one is you have to replace all the terminating variables to its equivalent non-terminating variables if such productions are existing by adding their equivalent productions. Okay. Now you see here clearly this is in Chomsky's normal form. This is also in CNF. This is also in CNF. This is also in CNF. But these two are not in CNF. So what I do here, for this, I'll add a new variable called VA and I'll add its equivalent production. That is VA is equal to, what is the definition of VA now? BTA. Right? And I can combine these two together and I can call it as VB. So VB will be equal to TA TB, right? So this entire thing will become VB, this entire thing will become VA. That is how I can convert it into Chomsky's form. That is what we have done here. Okay? So we have converted the given grammar to its equivalent, Chomsky's normal form. And you can see one more thing here. The definition of A, that is the second production, is TA TB. So for this, we will make its equivalent transition by adding V2. Okay, so now the given grammar was this, which was not in Chomsky's normal form. Later, we converted it into Chomsky's normal form. So in the conversion process, we can get a few things from here. What is it? First one, for any grammar, if it consists of epsilon production, useless production, or unit productions, first you have to eliminate these productions from the given grammar that we have seen in the last classes, how to eliminate epsilon production, how to eliminate unit production and useless productions. So after eliminating this, you have to perform these particular steps. What is it? Suppose if you have all the non-terminating symbols, terminating symbols in the production, replace with its equivalent productions and obtain the non-terminating symbol to add it here, right? This will be TA. And similarly, if you have more than two non-terminating symbols, break it into a new variable for a production to get it in Chomsky's normal form. Okay, so this is about. So look at this problem here. You have an epsilon production, right? So how do you eliminate this epsilon production? We'll take all the possibilities for this epsilon production. Epsilon production is equivalent to a variable called x. So wherever you have x in the given grammar, we have to replace it with epsilon to get its alternatives. So you can see here ax bx. What is the disturbance? Sarup. Okay. So now we have the production saying that S tends to ax bx is the production given, in which what we need to do is we have to replace x with its equivalent definition, that is epsilon. So what we do, we will consider the first x as epsilon, so it will be abx, right? Similarly, if you take the second x as epsilon, it will be axb. Similarly, if you take the third, both first and next x as epsilon, you'll get only AB. These are the possibilities you get, that is equivalent for your first production. Okay. In second production, you have x tends to AY, right? And you have x tends to BY. Now let us see what is definition of y. The definition of y is in turn x only. And there is another definition for c. So let us keep the other definition for y as c as it is. But now, if it is taking x, x can be epsilon. So we can take it a, or here if y is x and x is epsilon, it will be only b. So this is the productions without epsilon symbols in it, right? So this is what you can see here in the grammar. This is the grammar which is free from epsilon productions. And there is one more thing that you can observe. What do you call for this? It is a unit production. We have to eliminate such unit productions in the grammar. So how do you eliminate this unit production? By replacing the value of x with its equivalent definitions. You can eliminate it. Okay, now you check it. We have eliminated the unit production by replacing with its equivalent definition, right? Now this grammar is ready and you have to convert it into its equivalent CNF. So how do you convert it? First check what are the places in which it is not in CNF. This is not in CNF. This is also not in CNF. This is also not in CNF. Even this is not in CNF. Because we say that the grammar is in CNF if it is of the form x tends to xy, where both x and y are variables, or s tends to a, where a is what? Terminating symbol, right? So we have to check with these two conditions. So now what we do? We need to replace these things. So what I do here is I'll take three variables. Let us call it as TA, TB, and TC will be three variables, and I'll consider TC will give me C, terminating symbol C, TB will give me a terminating symbol B, and TA will give me a terminating symbol A, right? So these are the three productions that I will add. Now what will happen to the given grammar is, here this will become TA, TB variable, and this is TA again, and this is TB. This is TA, this is TB. See, TA is a single variable, TB is a single variable, TC is a single variable. Okay, so this will become TA, TB. Now you can, this also will become TA, TY, TBY. These two I am not going to change because they are already in CNF. TAY, TBY, and these are also in CNF. So these things we are not going to change. Now you can check here. S tends to TATB. This one, which I am highlighting, is already in CNF, right? Next, X tends to TAY is already in CNF. TBY is also already in CNF. This is in CNF. This is also in CNF. And this entire production is in CNF now, right? But the only thing which is not in CNF is these productions. That is, I write it here. S tends to T A X T B X is one production, or you have T A T B X, or T A X B. So these productions that I am highlighting here are not in CNF because there are how many variables in it? One variable, two, three, four variables. Here you have one, two, three variables. Here you have one, two, and this is TB. Sorry, three variables, right? So how to overcome this? I'll add new productions here. What are the new productions? Let us take a new variable VA. Now VA stands for TAX. This one. Now this entire thing can be replaced with what? It can be replaced with VA. Similarly, I'll add one more production, VB, which tends to TBX, where these symbols will be changed to VB, right? So using these two productions, now what you have here, TBX can be changed to VB, and this production can be changed to VA. Now you can check, this is in CNF, only two variables. This is in CNF, only two variables. This is also in CNF. This is also in CNF, and this is also in CNF. So now what we do here is, this first line of the grammar will replace with this line. At last, I have to take this TATB. Second line will be TATY, TAY, TBY, AB. Third one will be TAY, TBY, ABC. Next, we are adding these two productions, and these three productions will be the grammar. So finally, the given grammar will be converted to its equivalent CNF, something like this. You can take any variable name. I have considered it as VA, VY. They have taken it as E and F. And this was TA. They have taken it as A. Okay. So this is how we'll convert the given grammar into its equivalent context-free grammars. Okay. So now I'll write its equivalent grammar for your reference. What we have got here. It will be something like this. S tends to VA, VY, VB bar TA, VB bar VA, TB bar TA, TB, where TA is A, TB is B, and TC is C, right? And X can be defined as, now A is what? TA, right? So TAY bar TBY bar A bar B, and for Y we will take TAY bar TBY bar A bar B bar C. Now two more definitions are left out, VA, VB. So that you'll take it as, what is VA? TAX. And what is VB? TBX. So this is the grammar that you get. This is the grammar that is CNF equivalent of the given grammar. In the solution, what he has done, instead of calling it VA, he has called it as E, and he has called it as F. Hence this will be F, and this will be something like this. He has given different names. That's it. Okay. So instead of TA, TB, TC, they have taken ABC, capital A, capital B, capital C. You can take it any way you want. That's why you in place of TATB, you have AB, capital AB. Wherever you have TA in this solution, here you will be having capital A. Wherever you have TB, you will be having capital B. Wherever you have TC, you will be having capital C. That's the only difference. Okay. So this is about conversion from context-free grammar to its equivalent Chomsky's normal form. We have one more problem to be solved. So this is the problem we have. So how do we solve it? How do we solve it?
BA has one variable.
What?
Epsilon, remove the epsilon.
Yeah, we need to remove the symbol epsilon. So how do you eliminate it? These are the three possibilities in which you have to change it, right? So let it as S tends to
Yes, sir.
capital A, B, A is 1, or it can be BA, or it can be AB, or it can be small b, right? So S tends to small b is already in S tends to small b is already in CNF. Others we need to change. Okay, let us go to the second production. Here you have A tends to AB, or if A is epsilon, I mean S tends to AA. If this A is epsilon, then you'll get only small a. This is already in context CNF. So what we need to do here, the things that are not in CNF, that is this, and this has to be changed. So how we change it? We'll take a new variable called TA and TB, and now what we do? TA tends to A and TB tends to B. These are the changes we make. So this thing will become TB, and this will also become TB. This becomes TB, and this becomes TA. Now this is in CNF, this is in CNF, this is also in CNF, but the first one is not in CNF. So what we do? We will take ATA. I mean, you have ATB, right? We will take one more variable B, which stands for A, I mean capital A, TB. So now ATB can be replaced with what? B, A. Now this grammar is in CNF. So previously it was not in CNF. Now you can clearly check it. This grammar is in CNF. That is how we will convert it. Okay. So these are a few examples of Chomsky's normal form. Okay, so we'll stop the class at this point, and in next class we'll